Hello Titan Dev Team. Today we're going to be taking a look at our master material and all of the different things that you can do to get the most out of your setup. So to start off, we're going to just quickly cover how you go about adding the master material to your asset. The easiest way is probably to go into material, add a material instance, and then go in and set the actual parent to be mi_base material. This will assign all of the parameters to your asset and use that base material for your scene. Now, for our asset that we have here, I'm using this example that's been added to the desert region. We have this canyon rock asset. You can see that we have three texture inputs that we can put into our material. We have an albedo, which is our color, we have a normal, and then we have our surfaces mask. Now, the one that I'm seeing the most confusion about is the surfaces texture. So to cover that, we can have a look at this one here. Now, by default, we're expecting a set format for each of these channels. We're looking for grayscale textures that are being input into the R, G, B, and A channel. R, the red channel, is looking for a roughness texture. The green channel is looking for a metal, and the blue channel is looking for ambient occlusion. Finally, height is put into our alpha channel. Now, when we put our assets together like this, it will automatically pick the roughness, metal, and AO path for the red, green, and blue channel. But if we don't need a texture input for that, we can use it in another area instead. A great example of this for this asset is our green channel, the metal mask. We don't actually need a metal mask for this asset because there are no metal elements for it, so it's just black. Now, rather than this being a wasted channel, what we can do instead is we can use it in a different area if this asset has other uses for a mask. We can do this by removing the mask or the texture from this particular channel. So in our sets here, we can choose to use or not use those channels for the roughness, metal, and AO. If we disable those values, we can set a linear value, a single float value for that asset. So you can see here, I've disabled roughness mask, and now I can set that value as a single parameter. The same goes for metal mask. If I untick that value, I can set that value manually so that this value is now considered metal. Now, because I'm now using these as a single value, I can use that mask channel in other areas. So if our asset uses emissive or subsurface or is a mask, then we can actually start inputting those channels into these areas instead. If we use emissive as the first example, when we enable this setting, we get some additional options: emissive mask and emissive strength. So here we can specify which channel we want to use. So for example, if that green channel is empty, I can now put an emissive mask channel into it instead, and then use the emissive strength value to increase that strength. Because we don't actually have anything in here, we can't see it. But if I put it into the red channel, or maybe better yet, the blue channel, you can see that we get some differences on our emissive. You can see those areas that are dark aren't emitting as much as the rest of the surfaces. We can do the exact same for our subsurface. So if I enable subsurface profile, we get the mask channel option, which is going to expect another channel from here to be used. And then we can tell it to use that mask for that channel. Same with the rest of our asset. So if we have our subsurface set here, we can choose to use subsurface and use subsurface mask. We can also, with subsurface, tell it not to use the mask at all and just manually set that value. The same goes for our use mask option. If we enable use mask, and I'm just going to enable use subsurface here, or disable use subsurface, we get the mask channel option, and then we get the tick to dither the mask. Now this is particularly useful if we want to create kind of a faux translucency, and we can use dither to fake that. Now with this and with subsurface, we need to make sure that we are changing the actual blend mode that we're using for this asset if we want to use those properties. If you want the channel to use the mask properties, you need to set it to masked. And if you want it to use the subsurface properties, you need to change the subsurface, the shading model value to one that uses subsurface, either subsurface or two-sided foliage. If you don't set those parameters, then even though you set the properties in here, it won't translate, it won't use those values. Now you can see, because I've enabled masked, we actually start to see some translucency on this surface. Because we've set it to the blue channel, which is currently got an ambient occlusion map in there, we see that we start to see translucency on all of the blue areas. Now, if we don't want it to dither, that's really easy to turn off as well. We can use a hard mask just by using that value. And then you can also use the mask clip value to change the parameters to how much that's going to affect it. So we can kind of go in here and type in, let's say 0.5 to increase the value at which it'll clip that data out at. So we've got a few different options for you to reuse those channels in a way that's going to keep things nice and optimized, but also keep things packed well. So the next thing I want to look at is our RVT options. Now, if you haven't used RVT, that stands for Runtime Virtual Texture. And what this allows us to do is blend our assets together using a single world-aligned texture. In this instance, my RVT stretches for the entire landscape, and it takes in the landscape material as its source. So you can see here that when I enable RVT, we start to get this nice blend, both of the normals and the diffuse of this surface. I can change that value by increasing or decreasing my blend distance and blend offset. So you can see we can kind of increase and decrease that value as we need. This is particularly useful for blending assets into the world. Now, the last thing that we need to look at is our UV settings. And these can be some of the most complex ones to look at. We've got a few different options, and these have been designed specifically to support all of the different platforms that we need to make sure that Titan works for. Now, the first and default setting for this will be non-parallax occlusion mapped UV warping. So if we take our distance value and we increase it, you can see it's going to start warping and blending this asset to try and make it look like it has more depth than it actually does. I'm just going to set this to a little bit past, kind of broken, so that we can really see it working in action. Now, the nice thing about this is that you get very subtle height difference movement on that surface. So you can kind of start to see that that surface now looks like it's got some more displacement to it than it actually does. But the downside to this is that as we get to the edges of that surface, as we start to get a bit more to the tangent of the surface, we start to see a breakdown. We start to see that warping skew. So we need to make sure that we dial this in to quite a small and subtle amount. On top of that, we can use a much more expensive version of this process, which is called parallax occlusion mapping. Now, for this one, we can kind of increase and decrease our scale to get some nice occlusion. And if we increase our parallax occlusion mapping value here, you can kind of start to see that we get some really nice kind of looking changes to that surface. As we increase that, you can see it even more on that asset. Now, in order for this to work properly, you have to change the PDO scale, which stands for pixel depth offset scale, and reduce it down, because by default, the parallax is going to cause a masking on that surface. You can get rid of this completely if you turn off shadows on this asset, but you'll probably want shadows on your surface in some way or another. So my advice is to just turn that value down until you get a nice in-between where you get some shadowing on the cracks and crevices, but you still get that nice displacement of the surface. On top of that, we also have a world space option as well. This will disable the parallax occlusion mapping that you have on your surface because we can't do both. And it will blend based on world aligned normals for that surface. We can change the size of our asset as we see fit. And that's going to just do an automatic world aligned triplanar blend of our asset. Lastly, we've also got support for nanite tessellation on these assets. Now, this isn't something you necessarily want to add on. This is quite an expensive process, but it does add a tremendous amount of detail to your assets. You can enable this by going down to Enable Tessellation and turning it on, and then you can set the magnitude to set the scale at which it will displace the surface. Then all you need to do is make sure that your asset is supporting nanite. I've just turned it off on this asset for now, and I'll just turn it back on so that we can see it. It will then process it and give us that nice displaced surface. And that's actually making an increased geometry. So if we go into our nanite visualization and our triangles, you can see that's really heavily tessellated, this actual surface, in order to provide that displacement. Now we can go in and we can change that value. So let's increase it just so you can really see it. And that's going to give us some really heavy displacement of that actual surface. But it does give us the absolute best final view of that final asset. The good thing about this is that it also works with world aligned UVs as well. So this is currently in world space. We can disable world space if we want to and just use the base texture parameters, to which it will do that. And it will scale as well, so we can even change our texture scale dynamically as we go, and the surface will just adjust. So there's lots of different ways that you can use this material to give you the absolute best parameter possible, but it doesn't cover absolutely everything. If you would like more features to be added to this material, then you can put in a feature request on the Discord and we will take a look at it. And if it's something that we can make work from an optimization standpoint as well as a use case standpoint, then we will definitely look at adding that. The way that we've created the actual base material itself is that all of this base parameter data is stored inside a function. So it's very easy for us to go in and add custom data per biome as we need, or per asset type, or whatever we need. So again, just reach out on the Discord if there are any features that you've added, but hopefully this base setup will cover the majority of what you need. Good luck, Titan Dev team, and happy making.